Okay, we're going to do a short video on estimating. Okay, so we want to estimate function values and solutions. Function values, and those values might be written f of a, and solutions of equation f of x equals c, where a and c are numbers in the domain and range of f. Okay, so we have a function here. I've sketched it. We don't know. Yeah, we've got a scale. Okay, we don't have a formula for this function, so you can't calculate it. But you can look at the graph and see what its values are, and you can see what solutions to this equation would be. Okay, so examples. Estimate y when x equals -1/2. Okay, you have problems due shortly, in a couple of days, where you have to do this sort of thing. Okay, so when x equals -1/2, let's see, what does it mean for x to equal -1/2? Well, I'm going to do this in purple. Now let's see. X is -2 here, which means that halfway between -2 and 0 is 1, and halfway between 1 and 0 is 1/2. I didn't do a very good job of marking 1/2 there. It's a little bit, but okay, so here. So here's where x equals 1/2. Now, what we mean by estimate y when x equals 1/2 is basically estimate the y coordinate of the point on the graph that has x coordinate -1/2. So let's see. We have points on this graph. The x coordinate of this point would be -2. And then we move over and move over and move over to here. And now the x coordinate is 1. And we keep moving over and go to here. And the x coordinate is 0. So it looks like we missed -1/2. So we go back a little bit. And we see that when we're right above this mark, that's going to be the point on the graph where x equals -1/2. Now, you probably know that, but I want to make sure the explanation is clear to everybody. Okay, so here is the point where x equals 1/2. Okay, so this is a graph point. Where x is 1/2. And now we want the y coordinate. Okay, so we just project this point over to the y-axis. Now this is 4, so this is 1, 2, 3. And this is a little bit below 3, but much closer to 3 than it is to 2. And halfway between here, there'd be, 2.5. And halfway between there and this point would be about here. That would be 2 3/4, which would be 2.75. Looks like that's about 2.9. So it looks like the y coordinate is 2.9. Well, there's our estimate. So our estimate is y equals 2.9. Now, if we got draftsman tools and measuring devices and stuff, we could probably measure this much more accurately. But that's a pretty reasonable estimate. And even if we measured it accurately with tools and stuff like that, we'd never be 100% accurate. Okay. So these are estimates. And even if you have tools, it's an estimate. If all you've got is the graph, if you don't have a formula and can't calculate it. Now, if you do have a formula, like with the basic functions, the extended basic functions, you got a formula for those things, so you could easily calculate these results. But that's not the point of making estimates. The point of making estimates is learn to look at the graph and see what's going on. And also, sometimes You don't have a formula, and you have to make estimates. Okay, well, that's first order of business. That was easy, wasn't it? Okay, now I'm going to skip down to this third task. Estimate f of negative 1.7. Well, remember that on the graph of any function, sketch this down here. Actually, it's probably going to be in the watermark. Sketch it over here. Okay, if we've got an x here and we've got a graph, you recall if you watched the videos that were, video that was posted a few days ago, that this distance here, or this arrow, represents the value and the sign of f of x. Okay, its length represents the number and its sign tells you whether it's positive or negative. And of course, if we project over here, the y-coordinate here is f of x. So if we want to do f of negative 1.7, we're going to find negative 1.7 on this graph, and we're going to see what the value of y is for that point. That's all it takes. This picture should make that fairly clear. Well, here's x equals 1, here's x equals 2. Halfway would be about here. So that'd be about 1.5, negative 1.5. And negative 1.7 would be between negative 1.5 and negative 2, but somewhat closer to the 1.5, negative 1.5. So I'm going to say that here x equals negative 1.7. And now we could say, well, here's an arrow that represents f of negative 1.7. So and of course, if we project over here, we find that this arrow represents about negative 2 point whatever this is. Okay, looks like a little more than negative 2.1. It's more like negative 2.2. So we could say here that f of negative 1.7 is approximately negative 2.2. Well, that's good, but let's see what we can do with these other questions. Okay. And of course, we could make a statement up here. When we said that when x is 1/2, the value of the function is 2.9 or y is 2.9, that's saying that f of 1/2 equals 2.9. So I could even pen that in up here. So up here we have f of negative 1.5, f of negative 1/2 is approximately 2.9 from all of this. Okay, well, now we want to estimate x when y is 1.3. Okay, so we'll do that in pretty blue color. Estimate x when y is 1.3. So y is 1.3. Well, that would be, here's y equals 1, here's y equals 2. 1.3 would probably be about here, a little closer to halfway between this point and this point than it is to this point. Okay, well, we could say, okay, well, just go to this nearest point here. There's a point on the graph where y equals 1.3. And if we go straight down here, we find the x coordinate. Okay, this is a value of x when y equals 1.3 because there's more than one. So we could do this projection and we get one of our answers. And that looks like about 0.3. Okay, so this would be about 0.3. So this is about 1.3 And this is about 0.3 here. Of course, there are other points on the graph that have y-coordinate 1.3. This point, and it looks like the x-coordinate is about 1.7. And a point over here with the x-coordinate appears to be about, well, this is -1, -1.5, about -1.2, 1.15. You can make your own estimate. You can have your own opinion, but as long as it's a reasonable opinion, x equals -1.2 at this point. Okay, so we have three solutions. X equals -1.2, x equals 0.3, x equals 1.7. Okay, down here, when we estimated f of -1.7, our estimate was -2.2. Okay, one more estimate to make. We want to estimate the solutions of the equation f of x equals 2. Okay, well, f of x equals 2 means that the y value, because f of x is a y value, says that the y value is 2. Means that the y-coordinate of the point on your graph that solves this equation is 2. So, well, here's where y equals 2. Notice that we have 1, 2, 3 points here where y equals 2. Okay? The solutions are the values of x. When y equals 2, when the y-coordinate is 2. And just in case the watermark obscures this, let's go ahead and pick this up a little bit so you can see it. Okay? I think it might be okay, but you never know. Okay, so what we do is we come over here and we project down here. And we see that this looks like about, this is x equals 1. That's probably about x equals 0.8 or 0.9. Okay. So I'm going to say, I'm going to say 0.8. No, I'm going to say 0.9. Okay. So for this point, x equals 0.9. Now I don't have any good place to write that in. Okay. But I'll just say the coordinates of this point are -0.92. So our solution is x equals 0.9. So I'm going to write that down here. X equals, and it's -0.9. This point. Okay, at this point, we have an x-coordinate that, if this is 0.3, that's about 0.2. So this point would be 0.22. And then over here, we have another point. If this is 1.7, then this is probably, maybe it's still 1.7, but I'd say it's closer to 1.8. Okay, so write it like this: negative 0.92, didn't leave myself room, implies that x equals negative 0.9. Okay, and anyhow, that's a solution. And I'll write all that out over here just to be sure we have it. Then our 0.22 implies that x equals 0.2, and 1.82 implies that x equals 1.8, and these are the solutions of f of x equals 2, the values of x for which f of x equals 2. So solutions of the equation f of x equals 2 are the x coordinates of graph points where y, and y is, of course, your f of x value, where y equals f of x equals 2. The solutions are x equals negative 0.9, x equals 0.2, and x equals 1.8. Approximately. So I put a little wavy line over that equal sign. Actually stands for congruent to, but I think the meaning is clear. Okay, this is how you do estimates. And when you're asked to do an estimate with a graph of a basic function, even though you know its formula, well, you do that. Okay, this is what you do. So that, for example, if you got the 2 to the x function, remember that if x equals 1/2, you can't calculate 2 to the x. Matter of fact, you can't calculate 2 to the x for very many values of x at all. Okay, you can do it for integer values of x. You can't accurately calculate it. You don't know how to calculate it, except to punch it into a calculator, and we're not using calculators right now. Now, there's an exception to that. Okay, so we don't use a calculator to calculate e to the 1 or 2 to the 1/2, but we can estimate it from the graph. Okay, then maybe you go to the calculator and see how close your estimate was. Or if you want to know the value of x for which 2 to the x equals 1.7, well, you don't have a clue how to solve that equation. Well, maybe you do, because maybe you had some analysis in high school and stuff, or in other courses. But most people beginning this course don't have a clue how to solve that equation. At the end of the course, you'll find that it's pretty easy, but you've got to use a calculator, or you got to take the graph and make an estimate. And the advantage to being able to estimate from the graph is then you can see what the solution of the equation is. And if you happen to solve the equation wrong, you do a wrong step, it's not going to be consistent with the graph. Okay, the graph gives you a picture of the function. It's valuable in many, many ways. And you'll see as you go through the course what some of those ways are. Okay, well, I hope this is helpful to you on the assignment. And remember to look at the assignments page to find the video and the assignment. I'll send an email this time, but you need to be checking that page, okay? Okay, so I'm going to stop this.